Hi, my name is 𝗦𝗲𝗀𝗀. I'm the Group Product Manager of the Azure AI Vision team. I'm excited today to talk to you about GPT-4 Turbo with Vision. So I've been in the AI space for the last 13 years. I started out in speech, and I've been working on vision-based AI for the last 5 years. And we are living in a truly unprecedented time. Not a week goes by that there isn't some new announcement, some new breakthrough, some new research paper. The speed of innovation has just been incredible. My hope is that there's one scenario, one thing you take out of this talk that you can take back to your business and use that as an implementation and join these 50% of organizations who have already adopted AI in at least one of their business areas. So the world has been amazed at what large language models can do, driven primarily by the amazing GPT-4. But in reality, we as humans interact with multiple senses. It's not just language, it's speech, as well as visual, which is a key component of our communication. And they say that a picture is worth 1,000 words. Up until now, computers have really struggled to interact with us in the visual domain. So if we look at the large-scale foundation models that we have GPT-4, which has a deep understanding of text and language, Whisper with its deep understanding of audio, and then DALL-E with its deep understanding of generating images and art. And now with the addition of GPT-4 Turbo with Vision, we're adding a deep understanding of the visual element coupled with the GPT-4's advanced language processing. So we are giving the ability for our Azure services now to see. So I want to jump into a live demo. So this is in our Azure AI Studio playground. So I'm going to upload an image here and run this prompt. So the prompt I'm running, I'm giving it this input image here, and I'm saying you are an AI assistant which generates rentals. Generate exciting content for this image, but don't talk about content you can't see, and follow the format of an attention-grabbing title and provide a description that's only 6 sentences long. So we can see here the title, A Slice of Paradise, Your Dream Tropical Getaway. Step into a world where luxury and natural beauty entwine in perfect harmony. If you look further down, book your escape today and step into a world where the stresses of daily life melt away. So you can see that coupling the advanced understanding of the image with the language for the prompt is truly powerful. So let's do another example image. So in this case, we as humans can reason through this and see that this is a flood. And what can the model do when we ask it open-ended questions? So all I said was, what's going on in this image, and should I alert authorities? The typical classic approach with computer vision in the past was you'd have to build a specialized model that looked just for specific use cases, like in this case, doing a flood detection or water detection. In this case, the response is, I'm unable to provide real-time analysis. However, it appears there is a flooding situation. The water is murky around the building, and it seems to be entering the building. Yes, it would be appropriate to alert authorities to ensure the safety of people inside. Another interesting question you can say is, where is the water coming from? So in this case, again, using our brains as humans, we can look at this and say, yeah, there's no way that you can tell where the water's coming from. And GPT-4 Turbo with Vision can actually reason through that as well. It says, based on this image, it's not explicitly clear where the water's coming from, as there is no broader context. I'll talk about context a little bit later. It could be due to heavy rainfall and nearby body of water overflowing, or a broken water main, or other possibilities. So it's basically saying, hey, I'm not really sure, but it's really pushing you really should contact emergency services. One more demo in this area. So one of the really popular areas is helping with homework and these kinds of things. So in this case, we just drew this and we baked into the image, how long is this edge and what is the angle here? It really wants to go down. And the prompt was answer the question in the following figure and provide intermediate steps. So we can see that it's intelligent enough to reason through that actually there are 2 questions here, and you can see the response actually has step 1 to solve the first question and step 2 to solve the second question. And it's able to give you very detailed how to actually do the math calculation. And then at the end, it actually gives you a summary of 8.94 and then 26.57 degrees. All right, I'm going to switch back to the slide deck now. All right, for this next demo, we have an obstructed image. So I purposefully put the bounding boxes there to make it not clear so you don't have the full context. And this is my example where context is everything, and GPT-4 Turbo with Vision is the first large-scale model that actually bakes context in. If I asked anyone in this room, hey, what is this? Everyone would probably really struggle to come up with what that text is. And this is the classic computer vision problem with optical character recognition, is if you were looking at that word in isolation, what is the actual word? So if I ask GPT-4 Turbo with Vision, what is that? It says, hey, the text is not clearly readable due to the handwritten nature. It could be a signature like Mark. The other interesting thing is it actually knows, hey, there appears to be portions of the text that are blocked out and cannot be read. So if I reveal a little bit more, I had one person who's been able to figure out what this was at this point, but it's still pretty challenging to say, what is this? And so in this case, I changed the prompt a little bit. I said, extract all the text from the image and explain what you think this is. And GPT-4 Turbo with Vision responded back with this. It said, hey, this is milk, steak, and it appears to be a shopping list. And it basically makes the note that the image is still obscured, which is interesting. And we can see, I guess, if GPT-4 Turbo with Vision is actually correct. And it is indeed a shopping list when I reveal the whole thing. But again, this is why context is so important. The model itself is getting the context and realizing, hey, I see, milk, steak. And the response here is even more amazing, is when I give it the full image, it's able to perfectly translate what I'm trying to say there. Mayo, organic bread. Even more interesting is the note at the bottom. It actually gets the subtleties of what's going on. It says, where is it? The note on the beer item suggests a reminder or emphasis on moderation or limiting the purchase quantity. Cool. So another example, Power BI. For those who don't know, Power BI is our Microsoft Analytics platform. This isn't a fictitious example for sales data for the Contoso company. I'm going to literally just take this screenshot, paste it into GPT-4 Turbo with Vision, give it the prompt, you are an AI assistant which helps inexperienced users of Power BI. How do I filter this down to just Canada? And it's able to help me with this. And give me all the detailed steps of how I can navigate. It's not just Power BI, it's a wide range of things it can help you with, from Microsoft Word to Windows to Android to Mac OS and applications across the board. Even more impressive is, again, the visual deep understanding of what's going on. I can pass the same image in and ask it, in 2 sentences, summarize the key takeaway from this graph. which should be obvious, but then I ask it, in one sentence, summarize a non-obvious takeaway from the chart. So the high-level summary that it comes back with is that there is 61 million total sales, which is right, 1,363 average sales. It also calls out that the sports activities are hitting 27 million and breaks down the sales of rented sports versus purchased spa visits. What's even more impressive is the non-obvious takeaway. It basically says, hey, look, email is dominating the sales source type, even though you would expect social media to be a bigger driver in this day of social media. So for this next example, I want to show you the advanced language capabilities of GPT-4 Turbo with Vision. What I did is I just went online, got a bunch of translations for the word thank you across a wide range of different languages, and I wrote it down, took a picture of it on my desk, and I said extract all the text in the image was my input prompt. The output did a great job. It pulled all the words and did a perfect job of translating that or properly recognizing the text. My next prompt was, please provide the likely language for each word. A little bit more advanced. And it came back successfully, Japanese, Spanish, Hawaiian, Russian, Latin, and it properly determined, yep, this is actually what all these languages are. I said, hey, what are all these words actually saying? And it says, hey, they're all saying thank you in different languages. So I'm not I'm not an expert in any of these languages, so I said, hey, is there a possible mistranslation in this list? And when I was getting ready for this demo, I promise you I didn't purposely do mistranslations. I thought I'd actually done it right, but it turns out there are actually 2 mistranslations. I actually got Latin wrong when I was doing my searching, and I guess my Latin translation is thanks to you. I did some more searching afterwards and realized that was indeed correct. And I also realized after chatting, after seeing this and chatting with a Russian member of the team, that I actually misspelled the Russian word, and it actually should be spelled with an O at the end. So again, the GPT-4 Turbo with Vision has an advanced understanding of multiple languages and understanding of what is actually going on. So another example, graphs to code. This is a pretty popular one that people like. I literally took this image, pasted it. This was from one of our research papers that we published. And I just gave it the prompt, generate Python code to draw similar curves. It came back and gave all the code, including the imports that I needed to use, literally copied and pasted that into a file, ran it with Python, and boom, I have this. Now, yeah, I have to tweak it a little bit, but it was uncanny with how close it has gotten to the result. So I went into my garage, and I got some screws that I had laying around, and I just took pictures of them. These were some pretty bad screws that keep stripping whenever I was using them, so they were kind of in my throw-out pile. But I took pictures of the top, and I assembled this as a single image, just to be clear. So I put 1, 2, 3, 4, and that's baked into the image, and then I did the green circle. And I said with the prompt, the green circle is showing you a perfect screw head, and the remaining 4 pictures show the screw heads that you are testing. Please rate each of the screw heads of whether they're defective or not. So again, this gives it has a deep understanding of spatial orientation. It understands where my 1 is, my 2 is, and that those are next to each other, and the fact that I actually circled something and I'm referencing it. Mind-blowingly, it kind of comes back and it says, hey, the screw, it basically says, it kind of repeats back to me, hey, I'm going to use the screw head with the green circle as the non-defective piece, and I'm going to compare all of them against the reference. And then 1, it says, hey, the screw head is defective. And it amazingly says it has noticeable wear and damage with the intersections appearing eroded and misshaped, which is absolutely correct. For number 2, it says it's not defective. And then 3 and 4, it says, hey, those are defective. I'll go back. You can see, yes, indeed, those are actually defective. All right, how do we take all those amazing capabilities and build it into an app? So we've been partnering with the grocery technology and services company Instacart. Back in May, we gave them access to the preview of GPT-4, and they were able to build the Ask Instacart feature with natural language. We've given them access to the preview of the GPT-4 Turbo with vision capabilities, and they've been able to add vision to their Ask Instacart feature. So let's see what that actually looks like. So as I'm getting ready for the holidays, I've loved to make a family favorite recipe from grandma. So I'm able to snap a photo of the recipe. Using GPT-4 Turbo with vision, we can recognize grandma's handwriting, and it's converted into an ingredient list into Instacart. From here, I can select my ingredients, like the apples, the pie crust, and I can actually delete things that I don't want. In this case, I've already got ground cinnamon at home, and so I don't really need that. And finally, I can instantly place that order for the remaining items that I need and get them delivered straight to my door so I can get to baking and savoring grandma's pie. So it's as simple as that: snap, select, and savor. You'll be able to use this vision-enabled feature to easily understand handwritten grocery lists and recipes. We'll be testing this feature with a small number of Instacart customers in the next few weeks, and we hope to make this more widely available in the coming months. All right, you've seen all those baseline capabilities with GPT-4 Turbo with vision. Well, what happens when we add in the Azure AI services to that mix? And you end up with something that's even more powerful. So I'm going to show another live demo here. So while this is running, what you'll see is I've actually toggled this enhancement on. And so what this is doing is it's actually leveraging our Azure AI Vision services. It's providing that additional context into the GPT-4 Turbo with Vision model, and we're able to enhance on top of that. So in this case, the prompt was recommend some fashion items from this magazine picture. And it says, certainly in this picture, the individual is wearing a stylish olive green fur coat, et cetera, et cetera. But what's cool about this is leveraging the enhancements, I can actually get the exact bounding boxes now. You know, in this case, a dark blue turtleneck sweater, the navy blue trousers, and you can get access to all of this in the API and then do what you want with it. Another example is we've augmented the GPT-4 Turbo with Vision capabilities to include video. So in this case, I'm going to pull in a video file, and I'm going to switch over since this has already been uploaded, and I'm going to actually run this. So first of all, the prompt says you are a video security officer analyzing camera feeds looking for anomalies. Again, that kind of generic prompt, and with its understanding. First, provide a summary of whether there's an anomaly occurring that should be looked into further. And second, describe in detail what's going on in the video. I wanted to just show you just a brief clip of this. So it's some drone footage that flies around a fire in different locations. Okay, so here's the response that comes back. First, there is indeed an anomaly occurring and should be looked at further. There is a visible fire which seems to be growing in intensity and size. Second, the video shows an outdoor environment characterized by a mix of greenery and built structures. The anomaly is a fire that is visible in the lower left-hand corner. Initially, the fire is relatively small and contained, but as the video progresses, it appears to grow in size and in intensity. So what's actually going on here is we are actually leveraging our Azure AI Vision services, including the Florence model to actually pick out relevant frames from your query from the video. And then we're submitting that context into GPT-4 Turbo with Vision to actually have it describe then with its advanced reasoning what is actually going on. And in this case, answer the question, should I alert authorities? And the resounding answer is yes, you need to look into this further. All right, I'm going to switch back. Here's another example of the enhancements with video. In this case, we had a member of the team take a video around their car, and the input on this was, you're an expert in evaluating car damage from car accidents for auto insurance reporting. Have two sections. Section 1 should be the car details like license plate, car make, model, and the model year. And Section 2 should include only 6 sentences and give me a description of the car damage. So in the case, it actually comes back with the proper license plate, the car make, the model, the year is actually within the proper range and it's blue. You can see that it says the right rear side has sustained damage. It's characterized by deep scratches and scuff marks. If you go all the way to the bottom, it's interesting. It says the extent and nature of the damage suggests the vehicle was involved in a sideswipe accident or scraped against a rough surface. I asked the member of the team, hey, what happened to your car? Because it's pretty rough. And he's like, actually, I hit, those parking garage posts? He actually hit 2 of those on 2 separate occasions. So that's where this damage is actually coming from. All right, so I've shown you 2 ways now that we can do enhancements through object grounding. The second one is adding video. The third one is actually leveraging optical character recognition as a part of Azure AI services. So this is a standard Microsoft balance sheet from one of our reports. I'm going to suck that into GPT-4 Turbo with Vision, and I'm going to say extract it as markdown and use tables if possible. It gives some really good markdown output. I can change my prompt and say, actually, instead, give me some JSON. So it'll give JSON if I want to, suck it into something else. So let's dig into the extracted JSON a little bit. What you'll notice is there's actually some problems with that JSON, and there were some mistranslations or pullovers when it was analyzing the text. And so you can see where the numbers in these 3 cases, or it's actually 4 cases, got mistranslated over. And it turns out for financial docs, that's an important thing. Like the numbers themselves should be, accurate. What's amazing is you can actually toggle the enhancement, and we will use this as additional context into the GPT-4 Turbo with Vision, and we will improve that, or basically fix that. So we'll send that into the model, and it will be able to come back out with the proper results. One more example in this kind of theme. Imagine you're going on a business trip, and you're going to lots of different countries that have different currency. Again, another example where the numbers and values are really critical that you get them right, because you don't want to submit an expense report with the wrong values. So I take this and submitting it into GPT-4 Turbo with Vision. I give it the standard prompt, and I say extract the receipts as JSON. In this case, I give it what I'm specifically looking for. Hey, just give me total, currency code, and phone number. That's all I care about. So again, using standard GPT-4 Turbo with Vision, I get this resulting JSON. But if I examine it further, again, there's some errors with some of the numbers. There's errors with some of the telephone areas, and it gets some things wrong. But again, just toggle that enhancement button on. It'll leverage the Azure AI services, optical character recognition as an additional input, and boom, all those green areas that you see, we were able to fix that. All right, I want to invite now Dr. Ted Lappas to the stage to show how how a customer can actually use these enhancements in a real life workload.
Okay. Thank you for having me. I'm here to give you a quick overview of the work we do with Microsoft and the new GPT-4 Turbo with Vision model. My name is Theodoros Lappas. I lead the data science team in Satalia. We are the AI hub within WPP. And what we do is we work very, very hard to introduce AI into all aspects of the marketing process. Now, one of the most exciting additions to this effort has been the new GPT-4 Turbo model with Vision. It has given our tools a gift, the gift of perfect eyesight, the ability to see and comprehend visual data like images and video. But first, a quick WPP note. We are one of the world's largest advertising marketing companies in the planet. We serve companies across industries and markets. Our portfolio includes some of the world's largest brands, the most iconic brands on the planet. I think it's a testament to our commitment to excellence and innovation. Now, one of the things we do for our clients is produce high-quality advertising content. So a client shows up, and they ask you to create a video ad for a new product. They give us a brief, and our creative teams produce a first list of amazing ideas to basically address the brief. We pick up the ideas, make some initial draft video assets, give them to focus groups, collect the feedback, analyze it, pick the best idea, polish it, and then give it to the audience, basically, into the public. Now, this is a very creative, but also very, very slow, very linear process. A lot of time, a lot of effort, and a lot of subjectivity to bias, basically. So the question becomes, how can we do better? How can we combine human creativity with best-in-class AI to deliver the best possible content in the most efficient way possible? And we do this in WPP with a tool that we developed that we refer to as the performance brain. It uses GPT-4 Turbo with Vision to help us understand visual data and figure out what makes content perform well or perform badly. So let's see how it works. In this example, one of our human creators, one of our users uploads a first video asset, a draft, to the brain's chat-based interface. And then the brain uses GPT-4 Turbo with Vision to produce a very detailed summary of the video. And as you will see, it captures every single aspect of the video: the product, the landscape, the colors, the styles, and more nuanced things like the emotion, the messaging, the call to action. Perfect visual perception of both content and context. Now, we've been playing with this type of tools for text, for video to text, and image to text for a very long time. And I can safely say that GPT-4 Turbo with Vision is by far the best tool we've seen for this purpose out there. So having this ability allows you to then do this. The user asks the brain to recommend ways to change the content to make it appropriate for a Christmas campaign. It then responds with very specific interventions: a different landscape, a different color for the product, a different call to action. Now, these are very specific recommendations. They're not random. They're driven by data, by volumes of audience, performance, and content data that we keep feeding to the model to make it smarter and smarter and smarter. Now, one of the things to mention here is that the things you can change in the video are basically an exponential space of possible changes you can make. The brain uses custom algorithms, GPT-4 Turbo with Vision, and Azure AI Search to search this massive space and select the best interventions that can collectively lead to the best performance result, basically. Finally, a critical point here is that the human user is always in control. In this example, she rejects the call to action recommended by the brain and asks for different options. And the brain responds. It gives you a new table of options for the call to action, and for each one, it gives you a very specific performance estimate across different KPIs of interest. So in that setting, you can make an informed decision and select the best possible option for your asset, produce it, and then finally expose it to the audience. So human creativity enhanced by best-in-class AI. And that's it.
Thank you, Ted. That was awesome to see how you can bring, again, what you saw there was how do you bring the power of GPT-4 Turbo with Vision together with the power of the Azure AI Vision services. So for the last and final section, I want to invite Adina on the stage to show how are we integrating the GPT-4 Turbo with Vision capabilities with Azure OpenAI on your data.
Thank you, Thomas. Hi, everyone. So Thomas showed you earlier how context is everything. Context is important. And with Add Your Data on Azure OpenAI, you can bring your company's data and domain knowledge to augment the model's responses for responses which are relevant and accurate. And with the GPT model for vision, now Azure OpenAI on your data is possible on images. I'm going to show you how that is being done and what scenarios it enables. So in my demo, I'm going to use the 𝗦𝗲𝗀𝗀𝗀 outdoor company as the context. Maybe you remember this from an earlier keynote. It's a fictional company. It sells outdoor equipment. And it is using the GPT-4 Turbo model with vision to create a chatbot, a personal shopping assistant, where their users can ask for product recommendations. So in this image here, we have a prompt and an image. The image is of a tent setup, and the prompt is, recommend a tent like this for under $200. So without any context, the model will reason over the image and is going to provide an answer, probably from the knowledge that the model has from the training data, but it's not going to be a model from the 𝗦𝗲𝗀𝗀𝗀 outdoor company product catalog. But in this example, the answer is spot on. It's coming back with the Trailblazer X2 tent, which is a product sold by this company. And the way that works is because the 𝗦𝗲𝗀𝗀𝗀𝗀 outdoor company provided the product catalog with images and with product information as context to the model with Add Your Own Data. So that is the part that I want to show you. So here we are in the Azure AI Studio. I'm in the Chat Playground experience, specifically on Add Your Data tab. And the first thing I want you to notice is the deployment type. I have deployed here the GPT-4 Turbo with Vision model, which enables me to bring a data source which includes images. So I will upload here the product catalog for 𝗦𝗲𝗀𝗀𝗀𝗀 outdoor company. For a data source, I have three options. I have Azure Blob Storage. And for large number of images, this is the option that makes most sense. But we have a small demo here, so I'm not going to show you that. I'm going to jump to the next one. The other option is Azure Cognitive Search. You can build a search index yourself by creating a search index from the images provided, but this flow will create one for you. So next time when you come here, you can select that. And the last option is upload files directly into this experience. You'll do that for a small number of files, so that's the one that I'm going to show you here. When you upload files, you provide a blob storage resource where the images are going to be uploaded, and the cognitive search resource. And we are going to use that cognitive search resource to create a vector search index from the images provided and from the product catalog text information. I'm going to give that index a name, and I'm going to move on to the next step. Here, I'm uploading the files from the product catalog. Again, fictional products. I have here a bunch of tents. My demo is focusing on tents. And I'm going to select these images. I'm going to upload the images in the blob storage that I have configured. And then for each image, I can provide a text description, which I already have here, already filled in for all the images. So notice here, this would be the information about the product from the product catalog. Typically, this is long information. I'm keeping this one short for demo purposes. So you can see here, for this tent image, I have category is tent, product name is Trailblazer X2 tent, priced at $190. After I provide the images and the product catalog information, I can save and close. And at this point, the images are going to be ingested. The vector search is going to be built using Azure AI Vision. And that takes a minute. So I already have a search index created here. And I can come with the prompt and with the image. So I already uploaded here the same image. It's quite small, but it's going to become larger in a second. And I'm going to provide the same prompt as before. Recommend a tent like this for under $200. So this is a live demo. And you can see here the image. And we'll have to wait for the model to respond. And there it is. The model responded with, I recommend the Trailblazer X210 priced at $190, the same way you've seen before. The model selected this particular answer based on image similarity. So I want to show you what that looks and what that means. To the left is the image provided by the user. To the right is the image from the product catalog of the Trailblazer X210. The image similarity is determined based on vector search. So when we provided the images as context, the images have been processed. The vector embeddings have been extracted with Azure AI Vision, and the search index has been created. And when the user's image was provided, we are doing similarity, and we are doing a vector search, and we are selecting the top result. So in this case, the most similar image in looks has been selected, and that's why the answer provided by the model is for the top most similar image. Coming back to the playground, I'm going to follow up with a question: is there a cheaper option? If I can spell. All right, so we are running that prompt and waiting for the model to respond. And the model came back with the Mountain Peak tent and the Trailblazer single tent are both available for $150 each. So again, the model responded with information from the data source of the Contoso company product catalog, which has been provided as context. The last thing that I want to show you is how you can use prompt engineering to get these kind of answers in such a way where you can build it inside your own solution in a more, UI richer with even back with the product catalog images for these recommendations. So I'm going to ask here for recommend 3 options with price, file name, in JSON format. And notice here that I'm asking for the file name because the search index for each image will also store the file of the product of the image itself that was processed. So the answer can come back with the name of the 3 tents that we've seen before, but now in JSON format. And notice here, the model provides back the product name, the price, and the file name such that you can build a richer user interface in your application. So what you've seen here is the retrieval augmented generation pattern. By bringing your data with the RAG pattern, you improve the accuracy, the relevance, and the diversity of the responses of the model. When combined with Azure AI Search and Azure AI Vision, GPT-4 Turbo with Vision will transform the information retrieval. Now you can add your images in addition to your text data and use vector search for an enhanced chat experience. Today, text and images are provided as independent data sources, but where we want to go from here is to just content, where you can bring documents, images, and even video as context for the model to reason over. So that is coming soon. Stay tuned for a future announcement. That's all I had. Thank you. Back to you, Thomas.
All right, wrapping up, just a couple more things I wanted to mention. So all of the great technology you've seen today is actually built on Microsoft's 6 responsible AI principles. We apply these principles to research, policy, engineering. So if you build on Azure AI, you build with confidence. I want to show one more demo. So for those who don't know, Seeing AI is a talking camera app for people who are blind. In this example, we're actually integrating GPT-4 Turbo with Vision to provide vivid, rich descriptions for, in this case, the image. Imagine if you were blind and you were going to the aquarium with your friends. Imagine taking this picture and trying to experience what's going on. With the GPT-4 Turbo with Vision, you're able to get very detailed description. In this case, it says, it's area containing multiple starfish and water. Some of the starfish are partially submerged under the water. If you go further down, it says the water is clear, allowing a view of the starfish and rocks beneath the surface. Even more interesting is if you take this app, you can do Q&A now so that you can actually ask questions, whether it's what does the starfish look like, how many starfish are there, what about the pink starfish. Prior to this, we didn't have this kind of capability that you could go in such detail and help blind users actually understand what's going on in the visual world. We're rolling this out to the Seeing AI app actually over the next couple weeks, so you can stay tuned if you're interested. So hopefully this session has inspired you, like I said at the beginning, to take at least one scenario back to your companies and implement and adopt that. We're releasing the public preview of GPT-4 Turbo on Azure by the end of this year, but we are in private preview right now. You can use the QR code or the email address down there. Highly recommend you use that. That's Azure AI Vision at Microsoft.com. That actually will get you in touch directly with the feature team, and we would love to work with you on any questions you have, any scenarios that you're interested in. We are going to end the session here. We're not going to do a standard Q&A at the mics. I have the feature crew. We're going to stand up front on the floor here. So if anyone has any follow-up questions, we'd love to have you come down and talk to us. Thank you so much.